All right, so let's get a start with week 7's pump and impeller testing. The homework for this assignment has you preparing a spreadsheet that will allow you to take the data that we're going to do in the experiment today. It's got the upper section on the left, has some of the primary data we'll need, gravity, the tubing diameter, which I'll go over in a minute. That calculates the tubing area. Of course, the density of water is here, and then the tank level, which I'll also discuss. The table itself, you'll enter the various exit heights, and I'll go over that. And then finally collect the mass, voltage, and time that it takes for each one of the exit heights that we're going to experiment with. So we'll come back to this and show you more. Again, you need to get these formulas working correctly to calculate the power on the electrical side, the velocity and the flow rate and efficiency on the mechanical side. So let's take a look at the test setup. Alright, so the equipment we're going to need today, we've got a a regular postal scale. We're going to do some mass measurement for the water we're moving, some tubing, our pumps that we've been using, the electrical measurement that we're going to use today, a GFCI circuit protector, as well as a stopwatch, in my case my phone today, and a pair of calipers. So let's start with the test setup that we're going to be working with the rest of the semester. This lower piece we won't be using today, so I'm going to disconnect this, carefully take it off and set it aside. We're going to be recirculating our water for our tank, so we'll set this under here and put our pump in there and attach our tube. So initially we're just going to set up a flow loop. It's going to recirculate it from the pump out through the loop and back into the tank. So we're going to have our GFCI set up here, which I'm going to go ahead and trip. And then we're also going to have our power measured to our pump by plugging the pump into this small meter. So if I go ahead and start that, we'll take a quick look at that. As you can see, the water is being drawn into the riser pipe and then drops back into the tank. Alright, so that gets us our basic flow loop. So the first measurements we'll need to take, I'm going to go ahead and hit test on this to reset it, is the head height, the tank level. So the tank level is about 1 3/8 inches down inside the water here. And then the other measurements we'll need to take are the measurements for each one of the exit ports that we're going to have. So for our first one, it's about 7 3/8 of an inch. And for our second one, about 11 3/8, 15 3/8, 19 3/8, 20 3/8 approximately. So we'll collect all that data in class and put it on their spreadsheet. Let's go ahead and take a quick look at that. So again, this portion of the spreadsheet is going to calculate the head height. And so let's talk for just a second about head height here. So looking at a quick sketch of our pump, we've got our pump submerged in water and we're providing electrical energy in. The tank level of the water is the primary importance here, and then the exit height. So if the pump is moving the water up and exiting out the top, we're going to do our mechanical energy, which is both kinetic and potential, in the output here. Now the important part is the exit level and the tank level. So it's this difference that makes up the head height. And so your spreadsheet should complete this calculation for you. Let's take a quick look at that. When I took the data earlier today, I got 7.5 inches, 11 3/8, 15 3/8, etc. So I have this cell, which is our head height, being calculated from this cell and the tank level cell. A few minutes ago I said it was 1 1/4. Earlier today I had about 1.5 inches of water in there. So right now it's about 15 centimeters or 0.15 meters, and that's the result of converting this to meters and then subtracting these two and then converting it to meters. And so these cells do that calculation for us. Once you have that done, of course, you can copy, since the system won't change, you can copy all of that down into the lower portions of the spreadsheet. This first one will be for the original impeller, and then each of the student impellers will be done in different tables. All right, so let's go back and look at the experiment again. So one of the things we didn't measure was the exit tube. All right, so what we're going to do, since we're forcing the water through the tubing, through this fitting, we're going to go ahead and turn on our digital calipers. I want everybody to kind of measure and check the, turn it on, hit the right button. Measure the inside diameter of this exit tube. This is one of the ones you'll need. So this is 4.5 millimeters. 4.5 millimeters, and that'll go in. You can switch that to inches, and it's 0.18 inches. All right, so that's our flow loop, that's our tank level, and that data gets entered onto the spreadsheet. All right, so we've got our flow loop running here, and the next thing I want to make sure you're familiar with is the electrical measurements. And so again, we're running our power through this small meter, and this meter is going to provide us with the voltage and the current. And this is our first introduction to these electrical measurements, and fortunately it's pretty simple for us today. So it's measuring 120 volts and it's providing 0.06 amps. It does a rough calculation of the wattage, but the value isn't precise enough for us, so we'll actually use the lower two values and put them in the spreadsheet. So while your pump is running at any one tank level, you want to go ahead and use 120, it might go down to 119, and then the 0.06 might change, might go up to 0.07 or so. So let's take a look at now the next measurement, and this is where you got to get your stopwatch out. I'll get my stopwatch going on my clock here. I'll reset it, and the next piece that we'll need is a small Dixie cup. So again, our goal is to measure the volume over time. So I weighed this amount of water earlier. It's about 85 grams. And so we're going to go ahead and see how long it takes on the lowest level to run 85 grams worth of water. And so I'll start next to this. I'll set this down. I'll switch hands here. We've got a decent shot of it. So I'm going to start on the left side. I'm going to tap it to get it started and slide the jar under right away. Here we go. And stop. So that took about 3.196 seconds, and it was about 85 grams of water. So we'll zero that out. The next experiment, we're going to pull the cap off. Go ahead and leave it running, point it down a little bit, stick it back on, and cover up the lower hole. Now, that was the data for the first experiment. You got time, you got electrical measurements, and you had the mass of the water move. Now we need to do that one more time, so I'll hit reset, and of course a little easier with having a partner. I'll switch hands here, and we go 3, 2, 1, and stop. So that's about 3.361 seconds. And we'll do that one more time as an example. Run it up. Stop it. Okay. We'll cover up the hole. We don't lose any water. And one more example here. 3, 2, oops, let me reset. Cancel. 1. And so that was about 3.75 seconds. So collecting that data along with the mass of the water. And again, just to check that mass of the water one time, I'm going to fill this cup about to there. And there'll be scales in the room for you to double check me. Switch it to grams. Set it on there. And again, the cup is about 2 grams, so it is closer to 90 grams of water when you get it that full. So we'll stop that. Put that back in there. And the last thing I want you to check, you're going to keep doing that experiment up to the top as high as it'll go. The last thing you'll do is lift up the tube and measure the exit height. And so the water is hovering around 31 and a quarter. possibly around 80 centimeters, and so 31 and a quarter inches. That's your last measurement for the day, and then you'll stop and do the other impellers that you're responsible for. So let's take a quick look at the spreadsheet. So I'm going to hit undo here because I've collected some data already. And so again, we've collected the mass of the water, the voltage, the current, and the time it took. You see the time's going to extend. At some point it won't actually pump, and so you won't want to put any time in for that. The exit height that we just looked at was about the 31.7 range, and I put that down here in the green section. Now with that data you'll want to create graphs. I already created some here. I'm going to slide over a little bit, and these are the two graphs that you want to create. Flow rate and efficiency. And so flow rate, you want the head height going across the x-axis, and then the flow rate in liters per minute. And again, this is sourced from your data that you're calculating here. So if your formulas are working right, this is fairly easy to generate. We'll also do efficiency, same thing. What you'll want on these two graphs is the original impellers data, and then your own personal impellers data on your graphs. So everybody's got to do their own graphs in that manner. So that brings us to the end of the data collection and the activities for week 7.